Hello, it's Mr. Otwell, the Math Master, helping you master math. And today we're going to be dividing radical expressions, also known as rationalizing the denominator. I've done so many of these problems. I want to give you my secret inside tips on how to do them in the most efficient way possible. If you find this video helpful, please remember, hit that subscribe button, turn those notifications on, give me a like, leave a comment. Did you like my method? Do you think that's a good one? What do you use? Any sort of feedback would be awesome. So without further ado, let's do this. So in this first video, we're going to be looking at some more straightforward examples, and then in some future videos, we'll take a look at some more complicated examples. So to get started, let's talk about what are we even dealing with. We're dealing with something that looks like this. We have a square root on the bottom of our fraction. We have a square root in the denominator. In mathematics, we've just decided it's not simplified. If you see some sort of expression that has a square root on the bottom, any radical really, then it's not simplified and we need to do some simplification. What we're doing, the process is called rationalizing the denominator. All that means is getting the square root out of the denominator. So you might be asking yourself, well, how do you do that? You're here, you're in the right place. You're gonna learn it right here in this video. So I have done a lot of these problems and I just wanted to share with you how I go about them. And I feel like for the most part, there's so many different ways to do all of these problems. I'm going to show you how I tend to do them just the fastest. If I'm trying to get them done as quickly as possible, then I'm going to show you that. In this process, I will be showing a lot of steps. It'll be a step-by-step explanation of how I get there. So I'll show all of my work so you'll be able to follow where I'm going with it. But it's really going to allow you and equip you to be able to do it a lot quicker, where you won't have to show as much work and still be using those foundational ideas we have about simplifying radicals. And so if you're not quite sure about how that works or why some things are happening, go check out my video on simplifying radical expressions. I'll leave a link down in the description. I've got a video just teaching about it and then just a few examples of simplifying it that are a little less intimidating without the fractions and stuff. So make sure to check that out if you need some extra help. So once again, the goal is to get the square root out of the denominator. What I like to do first is simplify this square root. Whatever square root is in my denominator, I want to simplify that as much as possible. Because what it does is it saves us time. It saves us work in the long run. So if we had square root of 12, remember from my other video, if we want to simplify a square root, we can break it into perfect square factors. So we know that 1, 4, 9, 16, 25, 36, etc. All these numbers are perfect squares. So if we can find perfect square factors, that will give us a nice little square root. And we know that a factor of 12 is 4. So the square root of 12 would be 4 times what? Well, we know it would be 4 times 3. Why do we break it into this? Well, we can separate factors that are in the square root. So this can just become square root of 4 times square root of 3. Hey, check it out. We know what the square root of 4 is, right? It's just 2. And then we have the square root of 3 left here. So we know that the square root of 12, when we simplify it, gets us 2 square root of 3. So the first thing I want to do is rewrite this in simplified form, at least in the denominator. So that will look like square root of 5 over 2 square root of 3. So once you've simplified the denominator, sometimes you can't do anything and just go from there. Oh, I forgot to mention, as always, I have some extra notes over here that we're going to be using. I used my product property of radical expressions here. I used my radical product property in this case here when I broke up the factors inside the square root. And like I mentioned, our first step, if we've just got one term in the denominator, nothing else, and there's only one square root in the denominator, then here are basically the 3 general steps you want to go in order to do this the most efficiently. So we've done step 1, is simplify the square root in the denominator. Now let's go on to step 2. We want to use the square root in the denominator and multiply by a clever form of 1. Let's take a look at this little property I wrote here. I said the square root of x times the square root of x just gets us x. All right, so for example, if we had the square root of 3 times the square root of 3, in this case, the number in the square root has to be the exact same, and we would just call that x, so it's 3. What's it get us? It just gets us 3. Now, why is this true? It's because of this property here, really. If we have 2 separate factors in the radical, we can bring them inside, right? So another way to write this piece of the equation is the the square root of 3 times 3, right? If you have the square root of 3 times square root of 3, we can bring those all in one square root. And then what's 3 times 3? Well, that gets us 9, but it's the square root of 9. What's the square root of 9? 3. Okay, this is why this property is working. This is going to be happening every time. So we're going to use this property here to help us out. Because remember, the goal is to get the square root out of the denominator. It made it a smaller number, so that helps us out. It made it 3, but we still have a square root in the denominator, right? How can we get rid of a square root? Well, if we have a square root times another square root with the same thing inside, that gets rid of the radical. You see that? We don't have a square root there anymore. So we want to multiply the bottom by the square root of 3. Because what's the square root of 3 times the square root of 3? Hey, we just wrote it over here. It's 3. It'll get rid of the square root. So you might be like, why not multiply by the 2? Well, we don't need to. It's not necessary. If we multiply by 2 here, we're actually doing more than we need to, and we would have to end up simplifying that down the road. So if we're just focusing on getting rid of what's under the square root, that's all we're going to need to multiply by is what's under the square root. So it would be really great, right, if we could just multiply this by square root of 3. But realize, if you only do this on the bottom, you're actually multiplying by 1 over the square root of 3. Well, we can't change the value of this expression. It has to be equal. And if we multiply it by this number, it actually changes the number itself. We can't do that. What is the only thing we can multiply by that does not change a value? 1. So we just want to get a little bit clever here. We need to multiply by the square root of 3 in the denominator, right? But we also know this has to be equal to 1. So if we know we need a square root of 3 in the bottom, what has to be on the top? What has to be in the numerator for this whole factor here to be a 1? It has to be the exact same, because square root of 3 divided by itself is 1. So really all we're doing right here is multiplying by 1. So it's not changing the value. But watch and see the beauty that happens. When we multiply our expression by a clever form of 1, and we chose this number specifically, we wanted it to be the exact same as what is in this square root. Now, look at what we got. We just have a fraction times a fraction. And using your multiplication of fraction rules, remember, you multiply across. We're going to multiply across. We're going to multiply the numerators. That gives us our new numerator. We're going to multiply the denominators, and that's going to give us the new denominator. So square root of 5 times square root of 3 is, well, look over here. If we're multiplying 2 separate square roots, we can bring them and make them 1 square root. So we can take the 5, put it under the square root, and take the 3 and put it under the square root as well. So we're going to have 5 times 3 still under the square root in the numerator. And then what is in the denominator? This 2 is still there, okay? 2 square root of 3 times square root of 3 doesn't just make this 2 disappear. It's still there. And we have a number that's a whole number here. When we're multiplying 2 square root of 3 times square root of 3, 2 square root of 3 times the square root of 3. Remember from my multiplication of radicals video, this 2 is outside the radical, so it just stays outside the radical. And it's a factor. Remember, if we write the 2 right in front of the square root, it's the same as 2 times square root of 3. Okay, so then the square root of 3 times the square root of 3, we can use this property right here. We can take both numbers that are under the square root and put them right there, right underneath the square root. So this will be 2 square root of 3 times 3. We can take this 3, put it in, take this 3, put it in under the radical. So then this is just equal to 2 times 3. Because look, 3 times 3, that's 9. And look right over here. Remember how we said a square root of something times a square root of the same thing? It just gets rid of the radical. You see how now the radical is just gone? And what's 2 times 3? It's 6. So this is what it will end up in the end. But let's just go ahead and show some of that work right here, because I'm going to end up erasing this in a second. So once again, referring back to this property, square root of x times square root of x is just x. So square root of 3 times square root of 3 is just 3. But what's happening right here? Multiplication, because these are factors. They're factors, so they're going to multiply together. Now from here, we just keep simplifying. That's the last thing. You simplify whatever's left over. So can you simplify a 3 and a 5 as factors underneath the square root? No. So we would just multiply those together. We get the square root of 15. And what's 2 times 3? It's 6. So this is what we end up getting, square root of 15 over 6. So I want to go ahead and show you that really, we did not change the value of this expression at all. This square root of 5 over square root of 12 is the exact same as square root of 15 over 6. Because remember, we just multiplied by 1. Multiplying by 1 does not change the value. So I went ahead and put in the calculator on Desmos what we started with and what we ended with, just to show you that really this is true. Okay, check it out. The square root of 5 divided by the square root of 12 is equal to this decimal. Really, it goes on forever. This is an irrational number. But then check it. I put in our solution, square root of 15 over 6, and I got the exact same number. These values are equal. All we're doing is simplifying. We're taking the first expression and making it look like something else. It's all about getting rid of that square root in the bottom, okay? If you notice in our solution, there's no more square root in the bottom. This is what the goal is, and we're not changing the value of the expression. We're just rewriting it in another way. So let's erase some of this writing out. So once again, square root of 5 over square root of 12 is equal to square root of 15 over 6. This is our solution. So coming back to my steps here, when there's only one term in the denominator, there's only one term, and there's only one square root in the denominator, that's all we got here. Step 1, simplify the square root in the denominator first. So we want to simplify the square root of 18. The 5 doesn't matter. All we're trying to do is simplify the square root of 18 because that 5 is just going to stay there. So the square root of 18 is equal to the square root of 9 times 2. I want perfect square factors when I'm simplifying a square root because we know 9 is a perfect square. 18 is the same as 9 times 2, right? It's the same. We know what the square root of 9 is. The square root of 9 is 3. And remember, we can break these up. So this just gives us 3 square root of 2. Square root of 18 is 3 square root of 2. Notice there's still that 5 there. So there is that 5 in front, and it's still times, because remember, if you write a number in front of the square root, it's the same as multiplying. So 5 times 3 square root of 2 is our new denominator. So we multiply what's outside of the radical, and we get 15 square root of 2 because we didn't change anything else. We just leave the 2 in the square root. So after we've done our first step, we want to rewrite our expression. So 3 square root of 5 over our new denominator, 15 square root of 2. Now you might notice we can actually do a little simplifying here, but I'm going to leave that until the end. Personally, if I was doing this problem, I would go ahead and simplify here. If you notice, you have a 3 and a 15 on the top and the bottom. So you'll be able to divide that out. It'll happen at the end too though, but just for the sake of sticking with these steps to make it just this algorithm that'll work every time, let's just keep going here. We want to use the square root in the denominator to multiply by a clever form of 1. Because remember, we still have a square root left in the denominator. Can't keep that there. We have to rationalize the denominator. That's what we call this. And we know that, hey, if we have the square root of something, we can multiply by the same thing, the same exact thing, and then get rid of the square root. So if we multiply the denominator by the square root of 2, we know that the square root of 2 times the square root of 2 will get rid of the square root. But you can't just multiply by the square root of 2 on the bottom because that changes the value of the expression. Remember, we have to multiply by a clever form of 1. So if we need our denominator to be the square root of 2, what does our numerator have to be? It has to be the square root of 2 as well, because this is just a clever form of 1. The square root of 2 divided by itself is just 1. If you multiply anything times 1, you just get the same thing, right? We can't change the value of the expression. All we're trying to do is get rid of that square root. So now, once again, we just have a fraction times a fraction. So we follow our rules of multiplying fractions. We multiply the numerators and multiply across, and we're going to multiply across with the denominators. So if we multiply the numerators, this 3 is outside the square root, so it stays there. And then remember, we can take the 5 and the 2 inside the square roots that are separate and put them under 1. So this would be the square root of 5 times 2 in the top. In the bottom, this 15 is still there. So we keep that 15 there. And now check it. We have what we want. The square root of 2 times the square root of 2 is just 2. So this cancels the square root, leaving us with just a 2. And remember, when we have that 15 right in front of the square root, that's just saying times. So because square root of 2 times square root of 2 is 2, we're still multiplying here. Now, last step, simplify what's left. So I would, before you multiply, go ahead and check your factors in the top and the bottom. Check them in the numerator and denominator. Can you divide anything outside the square roots? Well, yeah, we can. We have a 3 factor in the top, and 15 has a factor of 3. Remember, 3 times 5 is 15. So we can divide the top and the bottom by 3. So this 3 divided by 3 gives us a 1, and 15 divided by 3 gives us a 5. So when we divide 3 with 15 and we simplify that, we're going to leave a 1 there and a 5 here as factors. Now there's nothing else we can do. We just keep on going here. We can't simplify what's underneath the square root, but hey, you know what 5 times 2 is. So inside the square root, we're going to have a 10. 5 times 2 is 10. And then in the denominator, we have 5 times 2. So it's a 10. And right now you might be like, oh snap, check it out. We can just cancel these out. We can just cancel these 10s out, right? Hey, and there it goes. And we just get a 1 over a 1, right? The answer is 1. No, you can't do that. You can't do that. We can't do that. Undo all of that. We can't do that. Why can we not do that? Well, look, this 10 is under the square root. It's stuck. You can't mess with it. This 10 is outside of the square root. So you can't bring it into the square root. They're just there. We can't do anything else. This is our solution. And once again, we can check our answer and just make sure we got it right. This number needs to be equal to this number. So when I put in our starting expression, I get 0.31622 blah, blah, blah. It goes on forever, right? Then when I put in my solution, square root of 10 over 10, I get the same number, right? So these are rounded, of course, but we got the same thing. That means we know we're right. Our solution is equal to what we started with. And that's what's happening when we're simplifying. So hopefully you found that video helpful. If you did, leave a like, subscribe, comment. Let me know, did you find simplifying the denominator before we multiplied by our clever form of 1 as a helpful tip or not? If you want some more examples, click the link up there. I'll see you in the next one. Mr. Otwell out. Peace.